For as long as we have looked at the stars, we have known that the cosmos is not always a gentle place. The same impacts that delivered water to our world also ended the age of the dinosaurs. For all of human history, an asteroid on a collision course was a threat we could only watch. We had no defense, no way to fight back. Until now. This is the story of DART, the Double Asteroid Redirection Test. The mission's objective was as simple as it was audacious: to prove, for the first time, that humanity could deliberately change the motion of a celestial object. It was a test to see if we could one day protect our planet by giving a dangerous asteroid a tiny nudge, years before it could ever become a threat. The target was a binary asteroid system named Deimos, located millions of miles from Earth. It's important to know, this asteroid system posed absolutely no threat to our planet, which made it the perfect, safe firing range for this historic experiment. The mission-specific bullseye was the smaller of the two asteroids, a moonlet named Dimorphos, as it orbited its larger companion. The plan was a showcase of kinetic force. On September 26, 2022, the DART spacecraft, about the size of a vending machine, slammed into Dimorphos at a blistering 14,000 miles per hour. The world watched as the final images streamed back before the screen went black. The impact was a success. But the real question remained: did it work? Did we actually move an asteroid? The answer, confirmed by NASA after weeks of observation from telescopes across the globe, was a resounding, historic yes. Before the impact, Dimorphos took 11 hours and 55 minutes to orbit Didymos. The DART team had predicted the impact would shorten this orbit by at least 73 seconds to be considered a success. But the result shattered all expectations. The DART impact didn't just meet the goal, it obliterated it. The spacecraft's collision altered Dimorphos' orbit by a staggering 32 minutes. The tiny moonlet was pushed closer to its parent asteroid, its orbital path forever changed by a craft built on Earth. Scientists found that the impact was amplified. The blast of rock and debris, the ejecta, that was thrown into space from the crash acted like a rocket engine, giving Dimorphos an extra powerful push. This mission marks a new era for humanity. It is a proof of concept that solidifies planetary defense as a tangible reality. As NASA Administrator Bill Nelson stated, "This mission shows that NASA is trying to be ready for whatever the universe throws at us. For the first time in the history of our world, we have demonstrated that we are not just spectators. We have the power to protect our home." Look up at the night sky. For millennia, a distant, untouchable ceiling. Today, we see it for what it is, a destination. This is the story of our future. A tale written not in ink, but in energy, measured on a scale of cosmic proportions. We stand today as a Type 0 civilization, drawing power from the fossilized remains of ancient life. But the dawn of the next stage is on the horizon. A Type 1 civilization is a planetary one. It has achieved complete control over the energy of its home world. Imagine fusion reactors humming in every city, providing limitless, clean power, vast solar arrays drinking in sunlight, and the full might of our planet's geothermal and tidal forces harnessed. With this energy, we don't just solve climate change, we master our environment. Resource scarcity becomes a concept for the history books, and a united humanity finally learns to manage its cradle. But a cradle is meant to be left behind. This planetary energy is the launchpad for our next great endeavor, conquering our own solar system. This is the journey to becoming a Type 2 civilization, one that commands the power of its parent star. The feasibility is a matter of engineering, not fantasy. The moon becomes a shipyard. Mars is terraformed under a new sky. We will mine the asteroid belt for the building blocks of new worlds. But the ultimate tool of a Type 2 species is the Dyson Swarm, a megastructure of orbiting collectors, a net cast around our sun, catching a significant portion of its colossal energy output. With the power of a star at our command, humanity transforms. We are no longer bound to a single planetary surface. We become a solar species. And then, with our system mastered, we will look out, past the edge of our own small solar neighborhood, to the silent beckoning lights of other suns. The ultimate challenge, reaching another star system. This is the graduation to a Type 3, galactic civilization. The sheer distance is staggering. How do we cross it? The first voyagers may travel on slow boats, generation ships, self-contained worlds on millennia-long journeys. But with the immense energy of a Type 2 civilization, we can do better. We can use that power to fire continent-sized lasers, pushing vast light sails to a significant fraction of the speed of light, cutting the journey from thousands of years to mere decades. The pattern is clear. Each great leap, from planetary to stellar to galactic, is a leap in our ability to gather and wield energy. Energy is the currency of the cosmos. It is the force that will allow us to rewrite our physical limitations, to settle new worlds, and to ensure that the story of humanity is not a short tale on a single blue world, but an epic written across the stars.